Topic 12, Part 1. In this video, we're going to look at solving problems that involve volume. Specifically, we'll be taking a look at Lesson 12-2 and finding the volume of a cylinder. In Part 2 of the video on Topic 12, you'll learn more about cones and spheres. Lesson 12-2, Find volume of cylinders. In this lesson, we aim to find what we know, or use what we know rather, about finding the volume of a three-dimensional figure such as a prism, and apply that to finding the volume of a cylinder. You know about cylinders from going shopping at the grocery store, for example. Cylinders would be cans that are like a tube in shape, so your canned vegetables. If you ever purchase the stackable chips, those oftentimes come in a cylindrical can. You might also see them when you buy wrapping paper that comes in a roll that is also a cylindrical shape. In each case, that cylinder has a base that is a circle. And so that's what we're going to use to find the volume of a cylinder. Carefully read through example 1, and then we'll talk about how to apply the formula from the area of a circle, which is the base shape of a cylinder, and use that to find the volume, which is a three-dimensional measure that tells us how much space is inside that shape. In this first example, we have a fish tank that is in the shape of a cylinder. In order to find the volume, or the space inside that solid figure, remember volume is the space inside, you could fill that with cubes. But the problem is that you can't do that with a cylinder because of the circular shape. Instead, you would need partial cubes, and then it would be very difficult to be able to count those because they would be cut off at different points. So we instead use a formula that is a generic formula to find the volume of any three-dimensional shape. And that formula says V equals capital B times H, where V stands for volume, and the capital B stands for the area of the base of that three-dimensional figure. H is, of course, the height. So in this case, because the base of a cylinder is a circle, we have to use the area of that shape, which is pi r squared. Okay, the area of a circle is pi r squared. Since the shape of the base is a circle, that's the formula that we're going to plug in place of B. So right here. Then we're just going to use the dimensions on the cylinder and solve. In this case, the tank is large enough for the 25 zebrafish because you can see here the volume of the tank and compare that to what the volume of the tank needs to be for those 25 fish. So you have plenty of space for them. Now I'd like for you to take a look at the Triack. Let's work this one together. In this Triack question, it tells us already the area of the base of the cylinder. So it tells us the area of the circle is 78 5/10 inches squared. So that's going to represent the capital B in our formula. So we're going to use that right here in the area of the base. Next, we have to multiply that by the height, and the height of this cylinder is 11. So we're going to multiply that by 11. Do that and see what you get. In this problem, the volume of the cylinder is 863 5/10 cubic inches. In looking at example 2, we are going to solve a problem this time and find the radius of the can. So just like we did with area, we're going to be solving the volume formula for radius, which means they're going to give us the other pieces of information needed to solve. It tells us in the problem that the volume of the can is 300 milliliters. Then it also tells us that that's equal to 300 cubic centimeters. So because those two are equivalent, we're going to use the cubic centimeters in our problem to solve. They want us to find the radius of the can using 3.14 for pi and then the can has a height of 14 centimeters. So what we did is we took our formula. I'm going to expand that out. Pi r squared times h, because this is the B number. Remember, area of the base is the pi r squared. And we know the volume. We know pi. We do not know the radius, but we do know the height. So here what they've done is they've taken this pi times 14, and that's where they get the 43 and 9600ths. Notice that it's still being multiplied by the r squared because that's the piece that we don't know. So then in order to solve this, they're going to take the 300 and divide by 43 and 9600ths. And by doing that division, you end up with r squared equals about 6 and 8200ths. Now, that's not the radius. Remember, that's the radius squared. So in order to solve that problem, you're going to need to use the square root key on your calculator. So that key, remember, looks like the check mark and the division sign. So we're going to take the square root of the number 6 and 8200ths. And what we get is about 2 and 6/10. So that means the radius of that can is about 2 and 6/10 centimeters. We're going to go ahead and skip example 3 and move into some practice problems. Recall that finding the volume of a cylinder, which has a circle base, means that you're going to find the area of the base, area of that circle is pi r squared, and multiply it by the height. So even though the volume formula says V equals capital B times H, what we're using here essentially is pi times the radius squared times the height. Our practice is going to focus on a couple of problems just to get into the habit of using the formula. So let's start with question number 7. What is the volume of a cylinder with a radius of 5 centimeters and a height of 2 and 5/10 centimeters? Use 3.14 for pi. Okay, so here they've got a couple of things that we're going to do. So remember, your volume formula equals pi times radius squared times the height. So we have the pi symbol here. What we need is the r, and then we've got it squared, so that's 5 squared, times the height, which is 2 and 5/10. Now, 5 squared, remember, means 5 times 5, which is 25. And then we're still going to multiply that by 2 and 5/10. In doing that, we get 62 and 5/10 times pi. Now, it does tell us to use 3.14 for pi, so we're going to go ahead and multiply that out. 62 and 5/10 times 3 and 1400ths. And you should get 196 and 2500ths cubic centimeters. So that's the way it looks when you abbreviate the units. They're going to have a little 3 outside because you have a 3-dimensional figure. So when it says about in the question here, we'll go ahead and round that to 196 cubic centimeters. Now let's answer number 14. Toy rubber balls are packaged in a cylinder that holds 3 balls. Find the volume of the cylinder, use 3.14 for pi, and round to the nearest tenth. So the first thing that we're going to do is use our formula. V equals pi times radius squared times height. In this case, we don't have a radius. Instead, we have a diameter. So the diameter is 6 and 9/10 centimeters, which means the radius is half of that distance. So what is half of 6 and 9/10? The radius in this case is 3 and 4500ths. So now we're going to use that coupled with the height of the cylinder. That means the distance between the two circular bases. So the height here is 20 and 7/10 centimeters, and we're going to substitute those things into the formula and solve. So I'm going to help you get it set up, and then I want to see you solve it. And then we'll check our answers. So here we're going to multiply pi times 3.45 squared times 20 and 7/10. So the first thing you need to do is square the radius, which means 3 and 45/100 times 3 and 45/100. Okay, do that first. Then you can multiply by pi, and then you can multiply by the height. And what do you get? You get a nice long decimal. And luckily it tells us to go to the nearest tenth, so we'll say that that's about 773 and 6/10 cubic centimeters. The last question that we'll do together is number 17. It tells us that the diameter of a cylinder is 7 yards. So if the diameter is 7, then that means the radius is half of that measure. So 7 divided by 2 is 3.5. The height of that cylinder is 12 yards, and they want us to find the volume. So substitute in your values and come back and check your answer. And hopefully you got 461 and 58/100 cubic yards. That's all for cylinders. Next, let's talk about cones.